Welcome to Unit 3, Day 6. In this lesson, the first part of the lesson was an activity where we connected the idea of a factor to the idea of a root that we already had from the beginning of this unit. And the way that we did this was by taking a number of functions, and we started with a quadratic equation that was in factored form, and we simply made a function table, which meant that we took a bunch of x values and we plugged them into the function to figure out what the output would be. It looks something like this. If I take -4 and plug it in for x in both spots, I end up with -4 minus 3 times -4 plus 1, which comes out to be -7 times -3, which is positive 21. And that positive 21 becomes the y value. And I won't spend too much time on this activity for the purposes of this video, but briefly, if we continued that process for the rest of these points, we'd end up with the following y values. And we could then take these y values and turn to the equation in order to create a graph of the parabola, and the graph would look something like this. And based on what we know about the shape of a parabola, this graph then allows us to identify the roots, because the roots are the points where the graph crosses the x-axis. So from the graph, we know that the roots are -1 and positive 3. But we also end up noticing a deeper pattern, which is that these two numbers aren't just any old numbers on the graph. Looking at the table, you should notice something kind of special about these 2 points. And looking at these numbers and looking at factored form, there's another pattern that you can recognize. And I'll let you think about the reflection questions, which are on the right, and maybe even do a couple more examples in order to see these patterns more deeply. And I'll move on to the notes section, but don't neglect this first part, because this is where you develop your understanding in a way that will actually stick with you. The second part of the lesson, we looked at some definitions, starting with the definition of a root. And I know we've defined this before, but the truth is, if you really know what a root is, you would know that it's not just one thing. If we're looking at a graph, roots are the place, the function, crosses the x-axis. And just to give a little visual here, it might look something like this, where you have a parabola, and usually you see that there are 2 points. And the way we write our answer, if we're identifying the roots, would just be to say the x value of these points. So it looks something like x equals and another x equals. Well, in the activity from the beginning of class, we looked at a graph, but we also looked at a number of points, and they were in the form of a table with x's and y's, but that's really the same thing as looking at a list of points. And when we were looking at this list, for example, suppose we were looking at 1, 3, 2, 0, and the list could go on, we saw that there was another way to figure out what the roots are, because the roots were the points that have a y value of 0. In particular, the roots are the x value of a point with a y value of 0. And even though we used a different definition, we still are going to write our answers in this format with x equals, or x equals and x equals if there were 2 of them. And then we can use these 2 and the connection between them to actually generate a third understanding of what a root is, which is if we have an equation or a function, even without looking at the graph, even without calculating points, we can understand a root as an x value that you plug into the equation and get out a 0. To phrase this in terms of inputs and outputs, roots are an input that can be plugged in to the function to get an output of 0. Okay. Because this definition ultimately is actually the most useful one, but it's also the most abstract, let me give you an example. Let's suppose we were looking at the function f of x equals 2x minus 6. You can kind of think to yourself in your head, if I wanted this function to equal 0, well, I would plug in a number for x, and I know if it's really going to equal 0 at the end, 0 is the same thing as 6 minus 6. So I'm going to have to plug in a number that will make this first term equal 6, and oh, you can probably see that number is going to be 3. Well, that means that for this function, 3 is a root, because if I plug in 3, the output of the function will be 0. Although it's very easy to identify the roots of a graph, the truth is, as we move forward in your math career, this is the kind of root that more often than not you're going to have to find. And so there's a particular formula, or property, more properly said, that is going to help us do this. It's called the zero product property. You might remember it from Algebra 1. Formally, zero product property is if the product of two factors equals 0, then at least one of the factors equals 0. Let's decode this really quickly. You know that the product means multiplication, and factors are just any two expressions or numbers that get multiplied. So we're looking at a situation like this, and we're saying, if the answer is 0, then at least one of the factors, that means at least one of the original pieces, must have been 0 to start with. This should make pretty intuitive sense to you. If you think about plugging in numbers in parentheses here, the only way we're going to get it to equal 0 is if one of the two parentheses itself is 0 to start with. To paraphrase this zero product property, I would say what it really means is if you multiply two numbers, and the answer you get, 0, then one of your original numbers must have been 0 to start with. In the practice at the bottom of this page, I'm going to ask you to identify the roots in each situation and to explain why. In order to create a really complete explanation, I recommend that you refer back to these three definitions, because based on what information you're given, the correct explanation could sound different, because roots aren't just one thing. There are different ways to understand what they are. If you need a moment to complete the practice at the bottom, you should pause the video here. If you're ready to see the answers, then continue.